it takes what from the bulb to make it change from a liquid to a gas? So, Bethany, what was that?
Energy.
It takes energy. So when water evaporates from the thermometer bulb, it takes energy from the bulb to make it change from, Ava? Well, what is the water changing from when it evaporates? It starts out as a liquid, and it becomes a gas, yeah. It starts out as a liquid, it becomes a gas. So the first sentence says, when water evaporates from the thermometer bulb, it takes energy from the bulb to make it change from a liquid water, to a gas. Some of the water from these cotton balls, or the alcohol in this case, evaporated. It changed from a liquid to a gas. So it takes energy from the bulb. That means the bulb is losing what? Energy. So when the bulb loses this energy, the temperature reading goes down, because we saw both of the wet bulbs decrease in temperature. So let's see here. A very likely test question is, what is next? Oh, yay. I'll look over here a minute. When you sweat on a day with low humidity, when the air could hold more water vapor than it's holding, your sweat does what from your skin? It evaporates. And when it evaporates, it uses what energy to do the phase change. So when you sweat on a day that has low humidity, your sweat evaporates from your skin. That uses energy from you to do the phase change. Your body's heat gives it energy, so it can become a gas. So when that happens, your temperature goes, Elise? When your sweat evaporates, your body temperature goes up or down? Goes down. When you sweat on a very humid day, when the air is saturated with water vapor, your sweat can't do what? Evaporate. It can't evaporate because the air is already and as humid as it can possibly get is called saturated. Right. So when you sweat on a very humid day, your sweat can't evaporate because the air is already saturated. So I will just quickly go over the end here, and maybe next week we'll go over the study questions, or I might just make you a video for those at home once I get my sick kid out of here. Sorry, I'm all today. Anyhow, the composition of air. Since humidity changes so much, today it's raining, so that means it's likely to be very humid, but last week it wasn't raining and it was as humid as it could possibly get and very hot, which means there was a huge amount of water vapor in the air. Since humidity just changes with temperature and other factors, when we consider the composition of air, what percentage of each gas is mixed in together to make up air, we always consider the composition of air minus water vapor entirely. We just absolutely ignore water vapor because it can change so much. So, when we talk about air is made up of this much of this gas and this much of that gas, etc., we are always talking about when absolute humidity is 0. There's no water vapor in the air. So, these are things you really need to know for the test, and I hope I'm aimed at the board properly. Pretty well. Okay, so right here, nitrogen, which I'm going to call N2. Nitrogen gas really is a molecule made up of 2 nitrogen atoms. Nitrogen gas, I'll just write nitrogen. Does anyone know what percentage of the air at 0 absolute humidity is nitrogen, Joseph?
78%.
78%. And Joshua, how about oxygen?
21%.
All right, and after that, there are lots of other things like argon, carbon dioxide, and ozone, sulfur compounds, nitrogen compounds that make up the other 1%. So it totals 100%. That's good. With humidity present, if we did consider just this air in this room, which definitely contains some water vapor, if we have air with water vapor, would these percentages stay the same, go up, or go down?
Go down.
Yes, because the water vapor would, make up a part of it. That would be like me taking some Kool-Aid and then dumping in more water. The Kool-Aid would be more dilute. If I put in water vapor into the mixture, the air is going to be more dilute. So air with water vapor would have lower numbers, would have lower percents. So those are key things to remember for the test. Nitrogen gas is very inert chemically. That means it doesn't react with other stuff. If you are working with dangerous chemicals that might explode, you want to do that in a completely nitrogen-rich environment because nitrogen just won't explode. We actually pump the hoods full of nitrogen and just stick our hands in through holes when we're working with explosives so that they won't explode because they don't have any oxygen to burn. Nitrogen, a nice, safe, happy gas. It doesn't react with anything. But oxygen is very reactive. So remember a couple weeks ago we talked about how concentration is very important at determining the rate of a chemical reaction. The amount of oxygen that is normally found in air is really good for combustion, something burning. But it's not so much that things burn so readily and so violently that it's super dangerous. So the concentration of oxygen is actually really great. More oxygen than we normally have in the atmosphere would mean that things would be more likely to burn. We'll try that out next week. So, carbon dioxide is another thing that's found here in this other 1%. So there's not that much carbon dioxide right in the air. Just a small amount. But it's a greenhouse gas. There are other greenhouse gases. I know in the news you hear about carbon dioxide. Water vapor is a greenhouse gas, and ozone is a greenhouse gas, and there are lots of greenhouse gases. But carbon dioxide is also critical to life because plants use it to make their food, which is our food. So that's good. We excrete it. Plants need it. So it's like our waste gas is their necessity. And then they actually produce oxygen, which is what we need. So their waste gas is also what we need. All the greenhouse gases together, in particular carbon dioxide, regulate the Earth's temperature. Breathing for us, so let's see. If we call this air composition, normal air with no humidity, then if we talk about air we exhale, the percentages of gases from the air that we, exhale from after we've breathed are a little different. So would you think that the amount of nitrogen in the air we breathe out is the same, little less, little more than normal?
It's less.
It's a little less. Why?
The humidity?
Yes, exactly. It's a little less because there's humidity. We breathe out water vapor, right? And we said when there's humidity, it dilutes the other gases. So nitrogen goes down. Nitrogen is completely inert. We don't actually use any nitrogen. So it's not like the nitrogen amount is decreasing because our body took some of it. We don't use it. Everything that goes in goes out. But we also add to it, like water vapor and our waste products. So that's why it decreases. We don't use it. Oxygen, would we expect the amount of oxygen that we breathe out to be more or less than normal air? Joshua?
More, because it's the leftover oxygen that we didn't use.
Well, but it's not more than what we breathed in. We took some of it.
It's less, I'm sorry.
I knew you meant that. So oxygen, these are things you really want to learn for the test. Oxygen that we breathe out is 16%. So we don't use all the oxygen that we breathe in. We take it in, We take out a little bit of it, and we breathe out most of what we breathed in. We don't use it all. But our body can get what we need. And then what we breathe out, where is it? Carbon dioxide is 4%. That's CO2, carbon dioxide. Water vapor, I think, is also 4%. Yes, maybe. Okay, and then other gases remain kind of similar at 1%. So when you exhale, what is the gas that makes up most of what you breathed out?
Nitrogen.
Nitrogen. When you breathe in, most of the gas that you breathe in is?
Nitrogen.
This is like 2 test questions. You breathe in mostly,
Nitrogen.
and you breathe out mostly.
Nitrogen.
Okay, don't miss that. There's like 2 giant test questions, and it's just nitrogen a lot. Okay, so yeah, that. All right, I think that's as far as I'm going to get today, so I can evacuate the sick baby. Next week we'll go over, or maybe I'll make you a video to go over the problems.